Hi, my name is Abhilash and you're watching Code Spectrum. Today we're going to be discussing the non-exact differential equation. See, in the previous lecture we have already seen the exact differential equation, where the equation is stated as the partial derivative of f with respect to x and then y would be equal to the partial derivative of f with respect to y first and then x. But if it is non-exact, then the condition will be like this, just the reverse case. So for this differential equation, let's figure out the partial derivative of f with respect to x and then y, which means we need to differentiate the first part with respect to y partially. So we will treat the x as a constant and y as a variable, so it will give you 3 into e to the power x, because y is a variable, so we need to take the constant out, and also the variable has the power of 1, so we will decrement the power by 1, so it will give you y to the power 0. Okay, and also x is a constant here, so it will give you differentiation of 0. And now for this part we will treat the y as a constant and x as a variable, so it will give you e to the power x. Okay, so we have seen that these two values are not equal. It means it will satisfy the non-exact differential equation. So what you need to do is take a subtraction from each other. So on subtraction we are getting 2 e to the power x. Now we need to check by which term we can divide this term, the subtraction term, so that it may result to a variable. For example, in this case we have e power x in this term, so we may use that e power x as a denominator for this term. So we place e power x here. Now you can cancel out e power x from both the numerator and denominator, so it will result in 2. So now we will find the integrating factor by writing like this. Now you need to place 2 here, and now we need to write the opposite variable present here, because we have taken the denominator as e to the power x and we have a dy in front of it, so we need to change the variable which is dx and write it here. Okay, now the integration of 2 dx is 2x, so we can write the result as integrating factor as e to the power 2x. In the next step we need to multiply the integrating factor to the whole equation like this. So now we can solve this equation like this. We can multiply e power x into e power 2x gives you e power 3x. Also in this case e power x into e power 2x gives you e power 3x, and 0 times e power 2x gives you always a 0. Now if you try to check the exactness of the differential equation, let's figure out these two values first. To find the first term we need to take the x as a constant and y is a variable, so if you differentiate partially with respect to y for this term, you will get 3 into e to the power 3x. And for the next term we need to consider the y as a constant, but we do not have any constant term here. We need to differentiate the x partially, so we have 3x in the power exponent, so we will take 3 outside and write e power 3x. So it will definitely give you 3 into e power 3x. So now if you can see that these two are equal, it means the differential equation is exact now. So you can take the same procedure as I have stated in the earlier video. Make sure that you will get this function e to the power 3x into y plus x into e to the power 2x to over 2 minus e to the power 2x divided by 4 plus c. Now you need to put the value of x and y in this equation. Here the value of x is 0 and y is 1, so I put here 0 and 1, and already this function is equals to 0, so the value of c is given by minus 3 by 4. Okay, you can place the value of c in the main equation here. Okay, so this equation f x comma y is the final answer for the differential equation. I hope you have enjoyed the tutorial. For more videos like this, please subscribe to my channel and also press the bell icon so that you can be notified every time when I upload a new video. And next time we will do a new problem for this non-exact differential equation. So stay tuned and thanks for watching.